So, hello everyone, my name is Robertas Skalskas, and today I'm going to do a presentation about Node.js streams. So, generally, why streams are important? As my beloved colleague Giedrius has mentioned, we need to run code in a synchronous manner. Due to this reason, we should care about reading from files as well, especially in the cases when we are dealing with large files or large database tables or some heavy data sources which we're interested in. So, without further comments, let's move forward. So I will begin this presentation from the introductions. So in the introductions part, we are going to discuss what is a stream. So we will just look through the definition, what is the stream. Later on, I will try to compare streams with some more natural examples, which we find in real life. Further, we will investigate different types of streams, and we are also going to investigate why do we use streams in overall manner. Last but not least, we are also going to look through where streams are used in Node.js at its core. So let's move forward. So what is the stream? According to the definition, the stream is a fundamental Node.js feature, or in other words, data structure, which helps us to read data from a really large data source in a sequential manner. Boy, this definition sounds complex. We could look into an example which you can see in the right. I have made a diagram in which you can see three different types of streams. So at the top of the diagram, there is a readable stream, which by itself says that it reads input. Later on, that data chunk by chunk is moved into some sort of fancy transformations, which we are doing in our business logic. And after those fancy transformations, our transformed chunks are being moved to writable streams, where it is being written to our destination source, which can be a file, a database table, or some sort of other destination. I always find these definitions quite hard to understand. Due to this reason, I would like to compare streams with nature. So imagine that the big data source is a ocean or a sea, and in the sea there are a lot of water, which means that you could not process all the water which is inside the sea in a single time. In order to feel the sea or get in touch with sea, we can imagine that the tides or waves which are coming from the sea to the coast are the buffers. So the sea is transmitting us a chunk of itself by tides and waves, and all the obstacles which tides or waves encounter during the traveling from the sea to the coast are the transformations. So those transformations can be rocks, can be pressure differences inside the ocean, or other things. And once the wave or a tide reaches the coast, it becomes different looking from perspective, looking from a point of view how it began. So once it hits the land, it's totally different piece of information in comparison with the start. So let's move further. I do believe that this explanation is more understandable than the pure definition. So there are generally 4 different types of streams which you can encounter. So as I have mentioned, those types of streams include a readable stream. So by its name, readable stream is used for reading data from a large database table, from a large file, or a generator function by sequential manner, which means that we are not reading all the contents at once. We are reading that content by allocating a fixed amount of memory in our operating memory, And once that memory is being read, we are removing that memory, and thus our application consumes way less memory than it could use. Further, we have a transform stream. So transform stream is interesting in the manner that it accepts a data from a readable or another transformable stream, and it can transform, or in other words, mutate the buffer which comes into the transform stream, which means that we can receive a one type of a chunk in the input part of a transform stream, and we can spit out totally different data structure or modified data structure in our output. Moreover, we have a writable stream. As the name mentions, writable streams, our main focus is to write data which we are receiving into stream to an external data source, file, or a table. And we are doing those writes in a small pieces, which means chunk by chunk. For example, the same way we are charging our batteries in our phones. Once we plug a phone into the socket, we do not see that our phone has charged immediately to 100%. We see that the phone is charging, which means that the charge is coming from the socket into our phone, chunk by chunk, little by little, and once it reaches a sufficient capacity, it charges our phone in general, and we reach 100%. And last but not least, we also have another type of stream, which can be, which is called Duplex stream, and Duplex stream is really important because it's a combination of readable and writable stream at the same time, which means that we can think of a duplex stream as a stream which has a portion of functionality of readable stream and a portion of functionality of writable stream. As I have mentioned, streams are really really good way to streams are generally really good way to asynchronously read sequential data, and in order to read sequential data in a good manner, streams are based on event emitters, and as you can see in the slide, streams has got a lot of internal events which can be subscribable to. I have made a table where you can see relations among different streams and how those streams shared those different events. So each different stream has an event of closing, an event of data once it receives data, an event of end when there is an end, an error when an error occurs, and a readable, resumable, drain, finish, pipe, and unpipe. The one thing I want to mention, which is really interesting, are the two events which are called readable, which are called pause and resume. In case we have differences in our system on how fast computer can read data and how fast it can write data, we can get into conflict of back pressure. For example, if we are reading data faster than we are capable to write, we need to make some sort of pauses while reading from our source prior to writing to the destination, because otherwise our buffer, which stores all the chunks, will get clogged. Moving further, these are the examples of Node.js internal libraries where streams are used at its core. So we have a module which is called process, and the process has three different areas where it spits information. So we have a standard input, which means that if we are writing, let's say we are having a terminal application and we are writing some data into the process, we can read that data. once process absorbs that data, it gets spit out at data in standard output. And in case if there is an error during the process, some sort of error message could be spit out to standard error, and it can be done as a piped stream. We also do have a module which is called file system, which was mentioned by my colleague Giedris as well. And file system module has several helper methods, such as create read stream and create write stream, which helps us to write and read from our files which are in our file system in a streamable fashion. Moreover, we've got a socket structure in net module, which is one of the core things of HTTP servers and TCP communications between different processes as well. Moreover, we are using streams in archiving. For example, Node.js internally has a library which is called zlib, and zlib has several different functions, such as gzip, create gzip, create gunzip, and others, in order to take a bunch of files and archive them in a asynchronous, non-blocking way. Last but not least, we have a lot of useful functions in crypto library as well, which we can use in order to cipher the information we are designing to cipher. So let's summarize this section. Why do we use streams in general? I do believe that using streams are really efficient, looking from both a memory point of view and time point of view. Since we are processing things in small chunks, the things can be done parallelly, and those small operation does not take that much time as the operations which are occurring when you are reading from a large file and everything at once. Also, this approach is highly composable and efficient strategy in case you are doing some heavy lifting. For example, you are reading some different files from some cloud provider, let's say S3, Amazon S3 bucket, and at the same time, while you're reading those chunks, you are archiving those chunks and you're putting that information to a different bucket and so on. Using streams in these operations are really efficient. So moving forward, let's overview how streams can be created. And in this section, I will show you how we can create a readable stream, transformable stream, duplex stream, writable stream, and we were also going to overview how can async generators can be combined with stream pipeline. And I will also mention why we should use some of Node.js internal provided tools for piping a lot of streams together. So let's move on to the creation of readable stream. So let's start from the top. First of all, in order to create stream, we need to import original class of readable stream, which we can do from my stream Node.js library. In this example, I will also use a random bytes function from a crypto. Moving forward, there is a function which is called data generation. And data generation function is a generator. As you can see on the line number 4, function notation has an asterisk, or in other words, star, which notes that this function is not a simple function, but it's a generator. Moving further, we have a simple logger. You will see this logger in other slides as well. It just takes a message and console logs with a prefix in case of info and with a prefix in red in case of error. So let's move on the stream itself. So we are creating my custom readable stream in this example, and in order to create custom readable stream, we need to implement _read method. The underscore read method is a core method for a readable stream. However, it also has some other important methods which can be implemented, such as underscore destroy, etc. So what we are doing in this example, we are defining a chunk and we are saying that the chunk is an iterator result of a string. And we are checking whether our data generator has a next value, and and we are assigning that value to a chunk, and we are also checking whether the chunk is done. And in case the chunk is not done, we are also checking whether stream allows us to push a value. Why it's important to check this .push function in a while loop. It's interesting. Streams, while using this .push notation in a stream, it returns a Boolean value. And in case there is a back pressure and the second stream cannot accept more buffer at this current time, this .push function returns a false statement, which means that we can do a short pause between the reads in order to unclog our further streams and make them run efficiently. So in this example, we are just generating random bytes, and we are converting those random bytes to hex. And if you are curious about the result, it's really fast. If you would go through this example on your local machine, you could see that your terminal is going like crazy. So what is being done? So we are generating a random hex string of 8 bytes. And we are writing that, we are reading that from a generator, and we are spitting the logs into our console. And it can go forever, which means that things we are reading are not being put straight into our operational memory. Once it's read and it's not being used, the buffer is being drained, and we can proceed with further data. So let's move to the further examples. So creation of transport stream. You can see that the example is basically the same. The only difference is that we are importing transform class instead of readable class from a stream library. And we are creating different type of transform stream. So in this case, we are creating a stream which takes a buffer and returns buffer as base 64. So basically what it does, after taking a chunk, it converts it to string in a form of base 64. And after the mutation, we are taking the value of that base 64 string and make a buffer from it. In order to make the console log printing prettier, I also put a end of a line at the end of the push. And it's important to call callback after you're doing the push. The callback indicates that you are done with the chunk, and the libuv library, which my colleague Giedrius has introduced you before, deals with that callback in a separate native thread. In case you're curious of an example of this stream, so once we write, let's say, word welcome, we get a base 64 string of word welcome. In case we write 2, we have another base 64 string. And you can see in this example, welcome Node.js event loop. I hope that you are having great time. So let's move with the example of Duplex stream. So what is a Duplex stream? As I have said, Duplex stream is a combination of a read and write stream. It's really interesting because Duplex stream can have either one data source or it can have multiple data sources, dependent on the implementation or what you are trying to achieve with the stream itself. A great example of Duplex stream is a WebSockets. WebSockets do accept client connections in the server, and the clients itself do also accept messages from a server itself, which means that we are having a two-way non-blocking communication using events during which we are sending buffers of data which can be interpreted and used in our business logic. Moving forward, example of Duplex stream. So as you have seen this example of Duplex stream, its main purpose was to emit a message of ping. And that readable stream shared same data source. So once it receives a readable stream of ping, a writable part of Duplex stream catches the chunk, and it writes another chunk of message which transforms the word ping to pong. That's a really simple example. I just want you to know, to get familiar with Duplex streams. So moving forward. Last but not least, writable stream. So in case of a writable stream, everything is the same. We've got a writable class. We have a writable options in case we want to extend our stream with some extra fancy typing. So in this case, I have made a type which is called prepend input writer options, and it expects prepended value as a string. So we are creating a prepended input writer which extends writable, and that in comparison with others, this class has a constructor. And that constructor is a combination of aforementioned writable props and that type which I have created on my own. So since we are using in these examples the inheritance principle, we need to call a super method where we pass the options. And we also need to define prepend value, which is mandatory in creation of the class. We have a underscore write function, which has a method, which has a property of chunk, which is a buffer. Also, it has an encoding, in case we are curious what type of encoding our writable stream is receiving. And we, as previously, we have a callback, which in case of error supports an error object, and it returns void. So we can, prior to writing, we can also do some transformations if you wish to, or we can just send this file, for example, to another stream or to a file which we could open using underscore constructor, and we also would close it with underscore destroy method. Unfortunately, the capacity of slides are really limited. Due to that reason, my examples are quite short. Moving forward, this is example of writable stream which I have showed you just recently. So in case we are inputting some of text into our standard input, we are prepending the output with a some sort of value. So in this case, due to the fact that we are created class with the word prepended, we are prepending this word next to the input which we have provided to the standard input. Moving forward, this is really interesting. So it's possible to combine both streams and asynchronous generators. What does that mean? So generators itself are not a streams by itself, which means that they do not have events which can be subscribable. However, internal tool which is called pipeline supports asynchronous generators as well as streams to compose a pipeline. So we can safely use, for example, a readable stream and a asynchronous generator for data transformation all together. And in this example, I have made a pipeline of 3 composed asynchronous generators. So the first generator is used for generating a sequence, and the function which creates a sequence accepts 2 parameters. So the first parameter is limit, another parameter is throttle in milliseconds, and we are creating a number of integers, and we are sleeping for an amount of time in milliseconds, which we have provided in function definition. Further, our data is being processed by a function which is called powerify. So what powerify function does, it takes a chunk which is of type number from a previously executed generator function, and it powers the value of that chunk by a power of 2. And further, it yields the result back to the further stream. And lastly, the last stream, or not the stream, but generator, is a function which is called stringify. It accepts a stream, and it also iterates through the streams as a chunks. And during each iteration, it converts chunk to string, and for better visibility, it just prepends a end of a line after the iteration. So using async generators pipeline. So in case we are using this example, we could expect something like that in our results. So we have an initial value of 15. Let's say our further stream takes our powerify async generator takes a chunk. It powerifies that chunk, and our stringified value also takes the same value and just prepends an end of a line to that value. And this concept can be composable, which means that we can put as many of streams as we like in our pipeline in order to efficiently solve our problems or do things while we are iterating through data step by step. Things to be aware while using streams. It's useful to know that you should always use a pipeline instead of a pipe in order to avoid data leaks. Why is that important? In case you are using .pipe notation on a stream, you should explicitly handle an error on each stream, which means that you should subscribe on error to each different stream and have a separate error handler to each stream. And in case you are using pipeline as utility, which comes from Node.js core, you can put all those streams in one place, and you can handle errors in more centralized way, which means in a one asynchronous block, which could later on switch error based on your application error code, let's say so. Moreover, it might be quite tricky to write unit tests for streams. In some cases, it can be tricky, but in some cases, it can be beneficial. For example, if we are dealing with pipeline, it's useful to it could be useful to mock a pipeline utility by itself in order to check whether all the streams which are being passed to the utility are of the shape which we're willing to receive. And we could also mock the writable part of the stream, which usually interacts with some sort of cloud provider, as I have mentioned, AWS S3 bucket, we could mock the writable part of the stream in order to write the same output which we would write to S3, but we could write that output to a local file and check whether our implementation works end to end. Moving further, practical examples of using streams. Well, these examples will be kind of pseudocode, but I just want you to get to know streams better. So let's move on. In this section, we are going to talk about external data streaming from process to standard output, but in validated fashion. And we are also going to cover a really simple PDF generation from some sort of external data source. So moving forward, let's start from a runtime standard input data validation. So imagine a case where we have where we expect an input from a standard input, and that input can be anything. We can write any nonsense which we want to the standard input. However, if we introduce a generator, let's say, which in itself has a validation schema. In this particular example, I'm just using a third-party library which is called Joy in order to do a validation. And we are validating whether our input into the standard input is one of those three words which are mentioned in the screen. So those three words are help, run, or stop. So these are only three valid commands which are being supported by our stream, and in other case we are just returning another value which is also yielded as a buffer. So looking from example point of view, in case we are writing some sort of illegal command, let's say so. Let's say we are writing telesoftas instead of a help. So our standard output would yell at us by saying that the word telesoftas is not supported, and the only supported values are help, run, and stop. So moving further, we can use streams to generate things which we are transform. So in this example, I hope that you can see quite well, we are creating a readable source, which is an infinite generator. That infinite generator does a task every 1000 milliseconds because we have introduced a sleep function there. And what's happening every second? We are fetching some sort of data from an external API. In this particular case, we are fetching a random user profile from random.me API, which I do believe most of us are familiar with for mocking. And later on, we are yielding a buffer from that received data to the further streams. Please take a note that we are stringifying this data structure in order to push it as a string. Later on, this chunk reaches another function, which is called make PDF. And you can see that this higher order function accepts an instance of a browser, which means that it's a higher order function, which returns a generator itself. So in this example, we are using a browser instance, which is Puppeteer. It's widely used for end-to-end testing of front-end applications. However, in this particular example, we are going to use it to render a PDF document. So what we are doing, we are generating a constant of data. We are parsing that chunk which we have yielded in the previous stream. And once that data is parsed, we are reading a file which contains our handlebars template, which will build a HTML portion of our PDF. We have a compiled handlebars template, and we pass that parsed data to the template. And once the data is passed to the template, it's being rendered as a true HTML with those variables which we have received from an external data point, and we can set that content to a opened browser page and take a snapshot of the PDF itself, which can later be stored or moved to the another stream, depending on our needs. And the end result of such example would be like a quite simple user card, which represents our logo. You can see that some random person, which is called Devron T. Winkle, wants to join Telesoftas. I bet that it's a good decision. And I bet that you have already read why it's a good decision to join Telesoftas. So without further notice, let's move further. So final thoughts. I do believe that promises synchronous stuff, which my colleague Giedrius has mentioned before, are a really good combination altogether. We should care about our single thread environment in Node.js, and we should try to execute as much of asynchronous code as we possibly can. So, and if you are not using streams really often, I highly suggest you using those more often, especially in ways when you are dealing with files, archiving, or cryptographically encoding some data inside files, etc. So, have you got any questions?
Right. Thank you very much, Robertas, for a presentation and quite a deep dive into streams. I guess a lot of us learned something new today about that. So, a couple of questions from the audience. The first one, you mentioned Puppeteer. Don't you use Cypress for end-to-end testing yet?
Yeah, in front-end developer, people are using Cypress. Speaking about myself, I'm a back-end developer, so end-to-end testing is not my engine, let's say so. I usually do a lot of unit tests, a lot of integration tests, but not like end-to-end testing of the browser. But I definitely believe that Cypress is a better choice to do end-to-end testing because it's a framework to do that thing.
Yeah, fair enough. It's quite similar, but they both have different stuff as well.
Yeah.
So I guess that's a good point to settle on. People notice that you were using generators, and there is one question about that. What is the difference between yield and await? Because they seem quite similar, but they quite a different thing. Maybe you could expand a little bit about how they differ.
Yeah, so the yield works kind of different because we are yielding once there is a value. It's kind of hard for me to explain like in depth because it's a really, really deep topic about generators itself. Generators itself are really interesting, and at the same time they are tricky. And in these particular examples, we were dealing with asynchronous generators, which means that those generators also can run asynchronous code, which is being put as a callback into libuv, and it also can yield those results back to the further transformations or further processing. I hope that I have at least covered something from this question.
Yeah, it seems like it's a totally different concept. Await is more for handling asynchrony, and yield is for working with generators.
Yeah.
Yeah. All right. Right. What are your personal or Telesoftas in general thoughts, attitude towards functional programming with JavaScript or TypeScript?
What are my personal thoughts on functional programming? I do believe that people should not stick to one concept. Generally, programming language is a tool, and we usually solve business problem. You do not need to focus on one portion of paradigm. For example, you cannot tell that it's a right way to code everything in functional programming. At the same time, you cannot tell that it's a only good way to code things in object-oriented programming manner. I do believe that the combination of the tools which language gives itself, and the choice of software engineering makes a really good end result looking from business point of view.
Yeah, I would add that just people who are coming from different languages also shapes how we actually do, and there is no actually that much of a strict rules.
Yeah.
Right, so the last question, do you use Lodash or Lodash/FP?
I try to avoid like heavily bloated frameworks, not frameworks like utilities for doing some manipulation. Of course, those are tested, but at the same time, it can give us some tangled dependencies of different versions across different services. Nowadays, people are working in microservices environment, which means that we need to maintain a lot of different services at the same time, and it's quite hard to maintain same versions of libraries among those different servers. So I use third-party tools only when I see a necessity of using those. And in case it's really simple, it can be written in plain JavaScript, and it can be easily unit tested, and it works straight out of the box.
Yeah. Okay. Thank you very much, Robertas. That was the last question. So thanks for deep but at the same time simple presentation, and we'll move on.
So thanks to you all. I hope that you have enjoyed this presentation.